This is a diode. It is a semiconductor device that allows electric current to flow in one direction from the anode to the cathode and blocks it in the other. I will use a little analogy to describe what it does, as well as introduce 4 basic parameters you need to pay attention to when selecting a diode for your application. A diode can be thought of as the rusty spring-loaded revolving door used for crowd control that can only spin in one direction. To get the door to spin, each person needs to push on it with a certain amount of force, and this force must be maintained to keep the door spinning. Otherwise, the door will shut instantly. This represents a diode's forward voltage, the minimum voltage required across the diode to keep it on. Some people forget to consider this parameter when attempting to use a diode to prevent reverse polarity, but don't forget that a little bit of energy needs to be spent in order to keep that diode on, and at higher currents, this will cause the diode to get very hot. This leads to our next parameter, a diode's maximum current. If each person pushes even harder when the door is already spinning, the door will simply start moving faster, allowing more people to pass through, up until a certain point when the door will break due to the heat generated by the friction in the bearings. A diode's maximum forward current is dictated by the diode's ability to not get too hot. So technically, if you can find a way to sufficiently cool a diode, you can force as much current as you want. However, this is of course done at your own risk. Now, if people try pushing on the door in the other direction, the door will not move, and most people will not get through the door. However, the door is not perfect, so it will flex a little bit. If people push hard enough, 1 or 2 people might be able to sneak through. This brings us to the third parameter, a diode's leakage current, the amount of current that leaks through the diode when it is reverse biased. And then finally, if you absolutely apply so much force that you destroy the lock and let a whole crowd of people go the wrong way in an uncontrollable manner, then you have just uncovered the last parameter, a diode's breakdown voltage, the reverse voltage beyond which things start to get really bad. Great. Now we should intuitively understand the functioning principles of diodes and their key parameters. But that's boring. How do diodes work on a physical level? Why are there 1,000 different types of diodes? And how are these actually used in real life? So stick around, there's more to come.